Alright, so this is progress 10, I believe. Yeah, 10. Yeah, 10? 10. Alright, so update to the, since the little last like 9.5 update, got a bit done, more done on the electronics interface, you know, LCD and everything. Same deal as last little update. I changed up the encoder knobs design a little bit. Last time they were kind of this pointy knurling around the edge for grip. I kind of swapped that out because it's acrylic, and I figured those points are going to break off really quickly as long as they're kind of, as well as they're kind of sharp. So we went for I changed it up. Went to a spline based knurling, I suppose. I can show it off in the sketch. Also, I added a little bit of engraving to the top to tell you which way is positive, which way is negative. Should really be just intuitive enough to figure that out, but yeah. Anyways, you can tell, just use a spline right here. Divided this up into 4 sections here. Said the spline in these 4 different sections should look like, should go from here to here, and then from here to here, and should have, like, you know, tangencies and yada yada yada, and all these, the curvature at these 3 points should be equal, and kind of tweaked that a little bit until I got what I wanted, and then just did a rotational pattern with the sketch. So if I stop sketch, don't want to save this again because that's just going to be annoying to update all my other crap. But yeah, and then I did some basic, some simple cam on it. So oh no, it's invalid toolpath. Oh well, it's being silly. It's really a fine toolpath, but yeah, you can. I just did some, just did the cam using the new laser cutting cam. They officially patched it, made it an official part of Fusion now instead of just being kind of a beta. So I've been using that, and it seems to be working fine. You can tell that with the cut, I'm compensating for the kerf width, but for the etch, for these decals, engravings, kind of, it's going, it's not 0 kerf, it's like 1,000th, but it's, yeah, it's effectively on the line. So that'll, yeah, you kind of want to do them separately, just inherently, because one doesn't need to cut through and you don't need to worry about dimension. So that's a little knobby. Let's go to the assembly, electronics assembly now. Yeah. All right. So since last little update, I've changed out a couple things. So I did eventually go with putting the stepper drivers on the bottom of the board. Should really space them out just a tiny bit, but I don't know. Yeah, I don't know. I don't know if I feel like updating EagleCAD. Maybe when I finish the board, I'll just, like, I don't know, like, I don't know. Maybe I'll just, like, file the stepper drivers down until they fit. I don't know. We'll figure that out. But I'm not sure what the deal is with this. The joints didn't update when I updated the some of the components updated. But yeah, so I oh wait, yeah, I was going to explain that. So I shortened the distance between here and here, the board and the faceplate, because I need a little bit more room for the step drivers on the bottom, just to make sure everything has enough room to fit. But yeah, now it seems like they do, so that's good. I got all the engraving on the front panel, so that's nice, and did all the cam for that as well. I'll show that in a second. But what else I did was, oh yeah, I switched over to, instead of like an FTDI plug, what I eventually decided on doing was using a USB-B type connector on the front, and then having, it was originally what I was going to do is I was going to use the Arduino Mini Pro, and then have the actual FTDI chip, converter chip, USB to FTDI little converter chip on the board. But Two things came along. A, that chip is like $5 on its own, which is kind of ridiculously expensive. I mean, I was willing to pay $5 for just one chip, but I don't know. And then second was the Arduino Mini Pro really doesn't have enough digital I/O to do what I want it to do, because I have a lot of things going on. So I have all these buttons need a multiplex. That's like 9 digital I/O handled. This display needs like 8. These encoders each need 2, preferably 3, but 2 is fine. And then like the stepper drivers have a buttload that I need. So that's like 30 or something. I think I counted the exact number. It was like 34 total, something between everything. But but all I know is that I ended up needing everything. So what else? Yeah, other than that, nothing much has changed on the interface. Like I said, added decals, did all the faceplate, did all the cam for it, so that's nice. Yeah, cam and then a little bit more cam. Anyways, so that turned out nice. I might add my name to the bottom there. I'm not sure. I'll figure that one out. But yeah, so everything's labeled now. I got all the like 1s and 2s and 3s and pluses and minuses and stuff going on. And then I also went up and finished up the board itself. So this is what it's looking like. You can tell, yeah, there's a lot. There's this giant amount of buses over here. Like, there's just a lot of digital I/O I needed to do. So yeah, so I switched to Teensies because I really needed the pinouts. As you can see in the schematic, I used up literally all the digital I/O ports on this thing, which is like 34, I think. These are analogs, and I could have used an analog for a couple of the things, a couple of the inputs, but I didn't want to. Man, I'm tired this morning. Anyways, but I didn't want to, and doing analog read calls instead of digital read is a lot slower, or at least my understanding is it's fairly slow. I just need more experience with this stuff to say definitively, but my understanding is that it's going to be slower because it's doing analog, operations. So, anyways, but yeah, so I hooked up all those little threaded metal inserts to the ground plane. Got a couple voltage regulators from the input, from VCC to the board, to 5 volts, and then from 5 volts to 3.3 volts. This board shouldn't consume much power on the logic level side, so the 5 volts to 3 volts. It's the steppers that should be pulling most of the current, and those are just running directly off VCC, which is fine. And then here's the encoder, here's the matrix multiplex thingy-majigger for all the buttons. You can see they're laid out in 6x3 grid, but the actual thing is 9x2. I did 6x3 to conserve digital I/O ports, because that's 6x3. Did I say 6x3? I'm not sure. But I did that to conserve digital I/O because now we need a total of 9 digital I/O ports for the button array, instead of, if I were to go 9x2, I would need 11, because you need 1 for each row and column. What else? Oh yeah, there's the soft latching diagram. I'd explain it, but I don't feel like it. Display, USB input over here. Or control programming port, I suppose. Put a little LED on it so that when you plug it in, the LED turns on, so that's kind of neat. It's kind of a red herring. Like, it won't actually tell you if like the data connection's good or not. It'll just tell you if the cable's plugged in, which you can kind of tell visually. But I like it because it makes a little, I placed it strategically so that the LED right there is right above the USB port, which in the cam is right underneath this little LED, USB symbol. So now, you know, whenever you plug it in, the USB symbol lights up. So that's going to be pretty. Again, a bit of a red herring because it doesn't actually tell you if the USB connection is good. It just tells you that your cable's plugged in, which is, again, something you can tell. So back to the board real quick. Yeah, so I just threw down the little 2 power supplies go here and here. All the buttons go there. The way I figured out where all the components go is I literally took Fusion, looked at where the center of the components were, and then I just did a what's the word? I did a. It's not an official operation, but I just kind of went by hand and copied all the coordinates over. Yeah, moved around some of the power inputs to the side here. Not huge on the placement. Not my favorite thing ever, but it'll work, I guess. But yeah, yeah, a lot of, and then this board should be about ready to ship. I've just kind of been staring at it for the last couple days. I really should have sent it off to manufacturer like a couple days ago, but I don't know. I'm indecisive, and I don't want to jump the gun on this board in particular because it's going to be a little bit more expensive than usual. So I don't know. I really should get it shipped off soon here because I'm going to be running out of time in the school year any moment now. So yeah. So that's that. Hopefully the slide rule should be working by the end of the year. However, it's kind of looking like maybe. It's really hard to tell just purely because I'm slow and bad and terrible at getting things done quickly. Because I'm way too meticulous with everything I do, which is good thing, bad thing, I don't know. But yeah, hopefully this should be done by the end of the year. Still need to tidy up those belts, get those figured out on the back of the slide rule. Oh yeah. So I was thinking, instead of 3D printing those stupid pinion gears for the rack and pinion on the main thingy, what did I do with it? On the main, over here, instead of 3D printing these pinions for the big rack, gear tooth rack, what I was thinking instead of that was what we do is we cut it out of acrylic, the teeth themselves, and then, I don't know, probably press fit with a little bit of adhesive in there, it onto an aluminum shaft, and then chuck that up in the lathe, and then undercut this a little bit, just purely because the plywood's not exactly 1/4 inch, and because the plywood's not exactly 1/4 inch, and the bearing inner race is a little bit extended past the inside flange, so I need to take off a little bit of material. There's a little bit less material in there than there should be, I guess. I don't know how else to say it. But yeah, probably going to laser cut this. While I was up at MIT, these little knobs, I cut one of them on one of their laser cutters at Miters, and it turned out really nicely. I love how acrylic laser cuts. It laser cuts so nicely, but yeah, it came out kind of poorly because their laser cutter was like canted off to one side, so it wasn't cutting perpendicular to the table. So it was kind of slanted, but the teeth on this thing, on the knurling, came out really nicely, like really smooth. So I'm thinking that'll make the gear turn out really well. So we'll see how that works out. Yeah. Oh, yeah. I did all the stuck them all on a cut file. I'm thinking of adding a couple extra, like one extra knob, one extra gear tooth, just so I have a little bit of redundancy in case I want more. Trying to get these laser cut sometime soon here. I haven't been able to get my hands on a laser cutter for them because everyone is really annoying about their laser cutters. And I don't know. I hate workshops and community workshops because everybody's anal about safety and stupid things like that. They don't just let random people come in and cut stuff on their laser cutter, which is totally silly. I don't get it. Like, just any random schmuck I can imagine, but like, dude, I know what I'm doing. Like, I don't. It's a glorified like office printer. It's with just a laser instead of, I don't know, ink. Like, seriously, it's that simple to use. The way that the way you start your cuts in is just the way most people have it set up is that they just go in Corel Draw and hit print, like literally like just like you would to print to an office printer, and then that's usually all that's required. It's just that easy. But yeah, so that's my little 2 cents on that. Again, should have it done sooner or later here. Hopefully, I don't know. By sooner or later, I mean like, you know, a long time in the future. But yeah, it's getting there. It's getting there.